In this question we have the famous Fibonacci sequence, and they describe how it was in relation to rabbits that they created this. So let's solve it. Tn plus 2, bring across Tn plus 1, and bring across Tn. Convert to our characteristic equation, or characteristic quadratic. X squared minus x minus 1 doesn't factorize, so minus b, so 1 plus or minus the square root of b squared minus 4 by a by c all over 2a, which is 2. So we're going to have 1 plus or minus root 5 over 2. So we'll call alpha 1 plus root 5 over 2. And we'll call beta 1 minus root 5 over 2. We know that L plus M is equal to RT0, they're calling it here, which is equal to 1. So L plus M is equal to 1, which means that L is equal to 1 minus M. We're going to need to substitute in this question. Then we have alpha by L, so 1 plus root 5 over 2 times L plus beta, which is 1 minus root 5 over 2 times M is equal to T1, which is also 1. So I'm going to multiply by 2 first and replace L. So 1 plus root 5 times L, which is 1 minus M, plus 1 minus root 5. We're multiplying by 2. We'll get rid of the fraction on the bottom, and don't forget to multiply the 1 by the 2. So multiplying out these brackets 1 by 1, 1 minus M plus root 5 minus root 5M plus 1 minus root 5 is equal to 2. So it should be 1M, I'm just seeing here. So the M's cancel, and we're left with I'm not putting in my M's, so we're left with minus root 5M minus root 5M, so minus 2 root 5M would be equal to this 2 here, minus 1, which is 1, and then we're going to have to bring across root 5 is all that's left, so 1 minus root 5. So 2 root 5M, be careful with the signs here, is equal to root 5 minus 1, multiplying them both by minus 1. So M is equal to root 5 minus 1 over 2 root 5. Now you can get rid of the third on the bottom if you want. I'm just going to leave it like this. L is equal to 1 minus M, which is root 5 minus 1 over 2 root 5. And if we make this a single fraction, we're going to get on the bottom 2 root 5. 2 root 5 by 1 is 2 root 5. And then we have this 1 here will be in front of these two, so it's a minus 1 by root 5, so minus root 5, and then plus 1. So this is going to give root 5 plus 1 over 2 root 5 for L. So we have L, we have M. So let's write this second order differential equation out. So we have L times alpha, so root 5 plus 1 over 2 root 5 times alpha, which is 1 plus root 5 over 2 to the power of n. Sorry, that should be a 2. And then plus M, which is root 5 minus 1 over 2 root 5 to the power, that's my M times, beta 1 minus root 5 over 2 to the power of n is equal to Tn. The last part asked, you can obviously simplify that down in your own way, but find T12. I think T12 when we put it in here gives 233. So the Fibonacci sequence in a bit more detail.